Sine law applications, question 5. A flag on a hillside casts a shadow of 40 meters down the hill. If the angle of elevation of the sun is 50 degrees and the angle of inclination of the hill is 15 degrees, find the height of the flag to the nearest meter. Well, this example is actually for you to do as a practice problem. We have already done two examples similar to this, right? So first step is sketch the scenario and then solve using sine law. So try it yourself. You can stop the video at the moment and then work out a solution. Well, here is my kind of solution, right? So how am I going to do it? So let's first sketch the scenario. A flag on a hillside casts a shadow of 40 meters down the hill if the angle of elevation of sun is 50 degrees and the angle of inclination of hill is 15 degrees, find the height of the flag to the nearest meter. So let's assume that that's our hill. So let's make a hill, right? Let's say this is our hill, which is at 13 degrees, right? And on the hill we have a flag. So let's say somewhere here we have a flag, right? So we have this flag here, correct? So that's the flag. Now, angle of inclination of the hill is 15 degrees, so that means this angle is 15 degrees, correct? Now, second thing is that the sun is an angle of 50 degrees, right? So 50 degrees, let us say like this, shadow is being cast down the hill. So let's say that is how the sun rays are coming, and there you have, right? So that's the shadow, right? That's the shadow, and that forms our triangle. Now, whenever we say angle of elevation, it is with the horizontal. So we'll draw a line parallel to this. Do you see that? Parallel to this, right? And here also line parallel to this, correct? That is the line, right? This line and these lines are parallel. That is parallel to the ground. Now, angle of inclination is always with the horizontal, right? So this is your 50 degrees. What I'm trying to say is this is your 50 degrees, correct? This whole from here to here is your 50 degrees. Total is 50 degrees, right? But as you know, this is 15. This is 15, right? So how much is that angle? That is what you need to figure out. So let's kind of label it. Let's say our triangle is A, and this point is B, and this point is C. That is our triangle. And to work this triangle out, what we can sometimes do is we can drop this perpendicular here and consider that right angle if required. It may not be required at times, okay? But the most critical thing here is to find that angle. Well, so it is a flag on hillside casts a shadow of 40 meters. We know A to B is 40 meters, so we know this distance, 40 meters, correct? Now, and this angle is known to us. So what is this angle? Let me write point D here first, okay? So this angle is angle CAB. See, angle CAB is equal to how much? Angle CAB is 50 minus 15, right? 50 is that angle, so total is 50, and inclination of 15 will take away. So we have 50 degrees minus 15 degrees, correct? So that is 35 degrees is this angle for us, correct? So we have this angle as 35 degrees. Now, side known to us is AB. Therefore, actually, to apply sine law, which angle should be known to us? Right opposite to this side, this one. How will you find that angle? So for that, we will extend this and make this as a right triangle. You see now this is a right triangle, correct? Now since this is a right triangle, we know this is 90 and this angle total is 50, right? So that angle should be how much? 90 minus 50, that means this angle is 40 degrees, correct? That is, so we say angle ACB. ACB should be equals to 180 degrees minus this 90 degrees minus 50 degrees. So that is the angle, which is angle C here, right? So angle C is for us 40 degrees. So we know this angle. Once we know this angle, then it is easy to calculate, right? Find the height of the flag to the nearest meter. So now it is very simple. We can find B to C using sine law. So we say we need to find B to C. So say BC over angle opposite to BC is 35 degrees. Sine of 35 degrees is equal to the length of shadow AB, which is 40, right? 40 meters over the angle, which is also 40, right? So it's a sine of 40 degrees. From here, we know BC is equals to 40 over sine of 40 degrees times sine of 35 degrees. And we can use our calculator to find the answer. So we get 40 divided by sine 40 times sine 35, 35.69, which is 35.69. We want nearest meter, so it is 36 meters for us. Let me just calculate it once again. 40 times sine 35 equals to 22.94 divided by sine 40, which gives us 35.69, right? So we say the height of the flag, we say answer is height of the flag is to the nearest meter, so it is 36 meters. So that is how we are going to solve this problem. Okay, thank you.